early into chapter 3 at Christmas, so. But I am going through chapter 2 this year faster than I normally do, I feel like, so.
We're smart.
Oh, real.
We pick up things quickly.
Speak for yourself.
Well, you seem to pick up the other stuff for chapter 2 pretty quickly.
Alright, complex zeros and the fundamental theorem of algebra. So the first problem say to write the polynomial in standard form, so that just means FOIL or superFOIL or, as the case may be, and identify the zeros of the function and the x-intercepts of its graph. And so the zeros and the intercepts come from the original equation, and then the standard form is where we're foiling. So f of x is equal to x plus 2 times x minus the square root of 3i, and the I is outside the radical, times x plus the square root of 3i. So just something to point out here, it might have been in your notes, might not have been, but when we have these, when you have one of these, you always have the other, okay, with i's or with square roots, and this one just happens to be both, because of, there's some rule that says it, but I can't think of it off the top of my head. Just in here. Well, it was under the fundamental polynomial connections in the complex case, I think. Maybe not. Maybe not. I don't know. Anyways, regardless, when one's there, they're both there. So, let's go ahead and do zeros and intercepts first, and then we'll multiply this. So where are the zeros of this function?
X equals -2.
Yep.
X plus square root of 3i.
X equals square root of 3i.
Oh, yeah.
Yeah, we have both of them. So those are all zeros. These ones are obviously complex zeros, but
Can't see them.
and then my x-intercept is just at x equals -2, because they have to be real numbers to be intercepts. And it is possible to have more than one intercept in this case, we just don't. So now I need to go through and I need to multiply this stuff. I would start with this pairing of them over here first because it is a difference of squares. So it'll just make it easier. So I'm going to copy that down. And then I've got x squared, the minus plus, obviously that's canceling, so then I'm going to have minus the square root of 3 times the square root of 3 is -3. And then I times I is I squared, which is what? -1. So I'm just going to make that +3 there instead of having to do that. And then we just need to multiply that through. So x cubed plus 2x squared plus 3x, oh, not 36, plus 6 would be in standard form.
So functions can have multiple x-intercepts, but only one y-intercept.
Technically, yes, because if you, otherwise you would have 2 points in the vertical line test.
This isn't like the little we have a number laid out. They can't have two
Yeah.
that way, but they can have two that way.
All right, let's look at 4. f of x is equal to x times x minus 1 times x minus 1 minus I times x minus 1 plus I. So zeros are where?
X equals 0.
Yep, x equals 0. What else?
X equals 1.
Yep.
X equals 1 plus I.
Yep.
X equals 1 minus I.
Yep. So now intercepts would be where then?
Or x equals 0, x equals 1.
Yep. So then to multiply this, you can go ahead and multiply this like x times x minus 1 if you want. And then we'll do these two together over here, and then we'll multiply everything through. So that's going to be x squared minus x times, I'm going to bracket it off just because it's going to end up being a lot. So x squared minus x plus ix minus x plus 1 minus I minus ix plus I minus I squared. And then I'm going to cancel things out that can cancel. Ix and minus ix cancel. Plus I minus I cancels. I squared is -1, and it's times a negative, so that's going to end up being plus 1 there instead of that. So then I'm going to rewrite it just so we can actually see it. So x squared minus x times x squared minus 2x plus 2. And then we can multiply this through. So that's going to be x to the 4th minus 2x cubed plus 2x squared minus x cubed plus 2x squared minus 2x. And then just get it simplified. So x to the 4th minus 3x cubed plus 4x squared minus 2x. All right. Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include those listed. And what it really should say is, and those that aren't listed that are also zeros, because that's going to be the case with some of these. So 8, we're given -4, 1 minus I, and 1 plus I. So in this case, they actually already give us both of them. They've given us the 1 minus I and the 1 plus I. If they hadn't, then if they had just given us the 1 minus I, we would need to add on the 1 plus I. So in some problems, they're going to give it to you, and in some they won't, and you just have to go in and add them. So always check for that first and foremost before you do anything else. So these are all x equals these values. Okay, so these are the zeros of the function. So this is x is equal to -4, x equals 1 minus I, and x equals 1 plus I. So when I get my factors that I need to multiply, I'm almost working backwards from the problems that we just did. My factors are going to be x plus 4, x minus 1 plus I, and x minus 1 minus I. And then I end up doing basically the same thing I did in the last problem, now just multiplying. So x plus 4 times all this stuff. So x squared minus x minus ix. I think this is the same we had in the above one, but minus x plus 1 plus I plus ix minus I squared. So just like we did in the last one, I'm just going to go through and cancel this stuff. Minus ix plus ix minus I plus I. Negative I squared is going to be plus 1. So I end up with x plus 4 times x squared minus 2x plus 2. So that gives me x cubed minus 2x squared plus 2x plus 4x squared minus 8x plus 8. So x cubed plus 2x squared minus 6x plus 8. Would be that one. So I'm going to show you 12, but I'm not going to like multiply it out because I trust that y'all can multiply on your own, but we'll like set it up and then I'm not going to multiply it because you would be able to do that. So 12, I'm just going to put setup only. So 12 gives us the zeros, negative 2 and 1 plus 2i. So this is one where they don't write out both for you. You need to know that you need to go on and add what? 1 minus 2i. And then again, these are zeros, so you need to remember when you do the factors that what you would be multiplying is x plus 2, x minus 1 minus 2i, and x minus 1 plus 2i. And then you would just multiply like we did in the last one. But I think we're okay with the multiplying portion of it. It's probably just the setup. Let's see, 14. These say to write a polynomial function of minimum degree in standard form with the real coefficients, or with real coefficients whose zeros and their multiplicities include those listed. So we've got 14, negative 1, which has a multiplicity, and I'm just going to write mult of 3. And then we've got 3 that has a multiplicity of 1. So multiplicity, again, remember, just means however many times that occurs. So there are basically 3 zeros at negative 1 and 1 0 at 3. So we've got x plus 1 cubed, basically, is what that tells us, because it's a multiplicity of 3, times x minus 3, and that one is just by itself because it's a multiplicity of 1. And then we would just multiply it out. So a lot of times people see it better when it's actually, written out like this. And so whenever I have like 4 things that are getting multiplied, I'll do the first 2 and the second 2. If there's ever like a difference of squares, obviously I'm going to try to do anything that makes life simpler. But I'm going to bracket off what these 2 things end up being. So this ends up being x squared plus 2x plus 1. That's a perfect square trinomial. And then this other one, x squared minus 3x plus x, so minus 2x minus 3. And then we get to superfoil and multiply all that through. So x to the 4th minus 2x cubed minus 3x squared plus 2x cubed minus 4x squared minus 6x plus x squared minus 2x minus 3. So negative 2x cubed and positive 2x cubed cancel. X squared. I don't see anything else that directly cancels, so I'm just going to simplify. So x to the 4th, then I've got negative 7x squared, negative 6x squared, negative 8x, and negative 3. And so that's how you do those. Look at one thing really fast and then we'll be done, but I need to look up something really fast in the back. All right, number 16. I was right. I just wanted to make sure before I did it. Again, I'll mainly just set this one up, but they tell us that we've got negative 1 with a multiplicity of 2, and then negative 2 minus I with a multiplicity of 1. So what do you notice about this problem? They've given us what? Right. Yep. So they've given us the zeros. So they've given us 1 0 that has an I in it, but they haven't given us its opposite as well. So what would the opposite be that I need to make sure I add on?
Negative 2 plus I.
Yep. Negative 2 plus I. So the sign on whatever number is there stays the same. It's the sign on the I that changes. Now, if it was like 3i, obviously it'd be negative 3i, and so on and so forth. But, and this is also going to be a multiplicity of 1. Okay, so whatever the multiplicity of that term is to begin with, it's the same multiplicity on the one that you're adding on. Does that make sense? Okay. So then to set this one up, again, remember, these are zeros, so this is going to be x plus 1, and it's a multiplicity of 2, so we square that. And then I'm going to have x plus 2 plus I, and multiplicity of 1, so I don't have to do anything. And then x plus 2 minus I with a multiplicity of 1, and then we would just multiply through like we did. So are y'all okay with that? I don't need to like multiply them all out for you, do I? So yeah, so that would be the setup of that one. And then, you're welcome to go through and do that if you want, but you don't have to. I'm probably not going to do 21 through 26. Sometimes I do it and sometimes I don't. I need to look and see if you actually need to be able to do that as part of the AP stuff. If not, tomorrow we'll be basically doing what we did in the last section, but you could end up with some non-real factors as well. So we'll actually be writing the linear factorizations, which is all the factors written out for them. So anyways, we'll be finding all the possible, checking to see which ones work, and then basically taking those and writing the factors to get our original equation that, factors it out or whatever. So